Good afternoon, students. The last class we discussed the topic plane, equation of plane, and we discussed some questions. Okay, I think you studied all the equations. I told you to study the equations. Okay, and today we can discuss some more questions. See the equation. Equation of a plane through the point x1, y1, z1, x2, y2, z2, and x3, y3, z3. Okay, have you studied the equation? What is the equation? Determinant x minus x1, y minus y1, z minus z1. And the next row is x2 minus x1, y2 minus y1, and z2 minus z1. And the third row is x3 minus x1, y3 minus y1, and z3 minus z1 equal to 0. We are subtracting the first point x1, y1, z1 from each row. From the first row it is from x, y, z. Second row the second point, and third row from the third point. Okay, you got the equation? Then we can do one question. Find the equation of the plane through the point 2, 5, minus 3, minus 2, minus 3, 5, and 5, 3, minus 3. See, which is the first point? x1, y1, z1. Okay, the first point x1, y1, z1 is 2, 5, minus 3. The second point x2, y2, z2 is minus 2, minus 3, 5. And the third point x3, y3, z3 is 5, 3, minus 3. You got it? Okay. And substituting all these points in the equation. Okay. Instead of x1, y1, z1, we substitute 2, 5, minus 3. x2, y2, z2, minus 2, minus 3, 5. And x3, y3, z3, 5, 3, minus 3. Then the first row becomes x minus 2, y minus 5, z minus minus 3, z plus 3. And the second row is minus 2, minus 2. What is it? Minus 4. Minus 3, minus 5, minus 8. 5 minus minus 3, that is 5 plus 3, 8. And subtracting the first point from the third point, that is 5 minus 2, 3. 3 minus 5, minus 2, minus 3 minus minus 3, that is 0. Okay. By expanding the determinant, okay, along the first row, you will get x minus 2 into 0 minus minus 40, minus y minus 5 into 0 minus 24, minus of z plus 3 into minus 8 minus minus 24 equal to 0. Okay, then simplify, that is 16x minus 32 plus 24y minus 120 minus 32z minus 96 equal to 0. Adding all the constant term and transposing to the right side, you will get 16x plus 24y minus 32z equal to 248. Okay, that equation is in terms of x, y, z, that is known as Cartesian form. Then how will you convert this Cartesian form into vector form? What is the method? Yeah, we can replace x, y, z by I, j, k. Okay, and the vector form is r dot 16i plus 24j minus 32k equal to 248. Okay, you by heart the equation, then only you can do the questions. Okay, then we can discuss the next question. The next equation, angle between the two planes. Angle between the two planes. Angle between the planes r dot n1 equal to d1 and r dot n2 equal to d2. Angle between the planes. What is the formula? Cos theta equal to n1 dot n2 by modulus of n1 into modulus of n2. Okay. Then from the equation of the plane, how will you find the vector n1 and n2? For any figure, we can find the vector by adding I, j, k with the direction ratios. Don't forget, we can find the vector by adding I, j, k with their direction ratios. Okay, then how will you find the direction ratios? If the plane is in vector form, direction ratios are the coefficient of I, j, k. If it is in the Cartesian form, the direction ratios are the coefficient of x, y, z. Okay, is it clear? We can do one question. Find the angle between the planes 2x plus y minus 2z equal to 5 and 3x minus 6y minus 2z equal to 7. Two planes are given. Okay, and here the planes are in Cartesian form. Okay, sometimes it may be in the vector form also. Okay, then first, whatever it is, either in the vector form or in the Cartesian form, first you find out the direction ratios. Okay, you remember, if it is in Cartesian form, the direction ratios are the coefficient of x, y, z. If it is in vector form, the direction ratios are the coefficients of I, j, k. Okay, then can you say the direction ratios of the first plane? How will you find the direction ratios? It is in Cartesian form. That is the coefficient of x, y, z. That is 2, 1, minus 2. And similarly, the direction ratios of the second plane, 3, minus 6, minus 2. We got it? Okay. Then we can write n1, n2. What is n1? n1 is a vector along the first plane, that is a vector perpendicular to the first plane. Okay, then we can write the vector by adding I, j, k with the direction ratios. n1 is 2i plus j minus 2k. What is n2? 3i minus 6j minus 2k. Then we can easily find the angle cos theta. What is the formula? n1 dot n2 by modulus of n1 into modulus of n2. We got both n1 and n2. Okay, then find the dot product by multiplying S coefficient of I, j, k and find their sum. Okay, sum of product of the coefficient of I, j, k. Then take their modulus. Modulus of 2i plus j minus 2k is root of 2 square plus 1 square plus minus 2 square. And similarly, the modulus of 3i minus 6j minus 2k is root of 3 square plus minus 6 square plus minus 2 square. And we get the answer. The dot product is 2 into 3, 6. Plus 1 into minus 6 plus minus 2 into minus 2 plus 4, that is 6 minus 6 plus 4, 0 plus 4, 4. And the denominator root of 4 plus 1 plus 4, root 9, what is it? 3. And root of 9 plus 36 plus 4, that is root 49, 7. We got the answer 4 by 21. Then how will you find theta? It is not the exact value. We can write theta is cos inverse 4 by 21. Our answer theta is cos inverse 4 by 21. The next equation, distance of the point x1, y1, z1 from the plane ax plus by plus cz equal to d. That is in Cartesian form. Okay. In question, if it is in vector form, you should convert into Cartesian form. I think it is better. That is the easy equation. Is modulus of ax1 plus by1 plus cz1 minus d by root of a square plus b square plus c square. Okay. Then again, I told you that you should by heart the equation. Okay. Don't forget. Otherwise, you can't do the question. Okay. Distance of the point x1, y1, z1 from the plane ax plus by plus cz equal to d. What is the equation? Modulus of ax1 plus by1 plus cz1 minus d by root of a square plus b square plus c square. Is it okay? Then we can do one question. Find the distance of the point 2, 5, minus 3 from the plane 6x minus 3y plus 2z equal to 4. If you know the equation, we can easily identify what is x1, y1, z1 and what is a, b, c, d. What is x1, y1, z1? That is a given point. And here the given point is 2, 5, minus 3. That is x1 is 2, y1 is 5 and z1 is minus 3. Is it right? Then what is ABC? What is ABC? Direction ratios of the plane. How will you find the direction ratios of the plane? Coefficient of x, y, z. That is A equal to 6, B equal to minus 3, C equal to 2. What is D? That is the right side positive constant. And here D equal to 4. We got x1, y1, z1 and A, B, C, D. Substituting all the values in the equation. Okay, A6, B minus 3, C2, D4. And x1, y1, z1, 2, 5, minus 3. What is the equation? Modulus of AX1. That is A into x1, 6 into 2. Plus BY1, B into y1, minus 3 into 5. Plus CZ1, 2 into minus 3, minus D, what is D? 4, minus 4, by, okay, root of A square, that is 6 square, 36, plus minus 3 square, 9, plus 2 square, 4. Okay, then simplifying 12 minus 15 minus 6 minus 4 by root 49 is 7. Then answer is modulus of negative 13 by 7. Okay, we can take the positive value since it is inside the modulus. And the distance of that point from the plane is 13 by 7. The answer is 13 by 7. Okay.